Hello everyone, this is Dr. Mihir Shah once again with another video. This is again the third part of our last minute revision under the subject Operation Research, which is to cover the entire syllabus in the most easiest manner so that you all can easily pass. Okay, two videos have already been posted. Let us see the last topics under this particular video. Okay, now the next type of sum is based on the chapter linear programming, project or LPP. Under that, the formulation method. Again, a very simple topic. Now, let us see the very first sum based on LLP, tabulation method or formulation of LLP method. Okay. Now, the question reads out as a person makes two types of gifts A and B. It requires the service of cutter and finisher. Gift items of A requires 3 hours of cutters and 3 hours of finishers, whereas gift item of B requires 3 hours of cutters and 5 hours of finish time. The cutter has 250 hours and fisher has 200 availability of time on every month. Profit per unit of A is rupees 35 and B is 45. Formulate LPP. Now, whenever you get such kind of sum, the very first thing you need to identify whether the sum is based on maximization or minimization. So, very simple trick. In the question, if you see the word profit, remember it will always be maximization sum. If there is cost, it will be minimization sum. Okay, remember we always try to maximize the profit and minimize the cost. So in this sum, you can see in the last statement is given that profit per unit. So it's profit related. It means it is related to maximization sum. Okay, that's the first thing that you need to understand. Second, now check what are the two prominent goods, two prominent variables which are given to us. So I can see here a person makes two types of gifts, that is gift A and gift B. So always remember, make a table like this. Okay, we will have gift A. So now there are two things here, so I'll write here this is related to gift A and this is gift B. Okay, so there are two types of product, gift A and gift B. After that, it reads out that it requires a service of cutter and finisher. So now there are two types of services in this. One is based on cutter, one is based on finisher. So first, always remember note down first two products and then the other variables which are given to that. After that, given that gift A requires 3 hours of cutter. So these are all in hours. Okay, so these are hours, these are hours. So very simple now. Gift A requires 3 hours of cutter. So I'm writing here as 3 and 3 hours of finishers. So I'm writing here 3 here also. And then it's given that gift B requires 3 hours of cutter and 5 hours of finisher. The cutter has 250 hours and finisher has 200 hours. Okay, so availability. Now remember here one thing. They said for cutter the maximum hour which is available is 250. Remember, if this sum is based on maximization, so for maximization it will always be less than equal to, this is basically our constraint that you are writing. Okay, less than equals to, for cutter it is 250 hours and for finisher the availability time is 200 hours. So this is like a constraint that we are writing. Always remember, for maximization it will always be less than equal to. After that, okay, after noting that, the next thing what we need to note down is the function, the main function, whether it is based on maximization or minimization. So I'll just note down one more column here. Okay, so this is based on profit. So I'm writing here profit is going to be, they said for A it is 35 per unit and for B it is 45 per unit. This is it. This is all which was available from the question. So now let maybe write, let the number of units
manufactured B, this will be called as x1 and the second one will be called as x2. This is our tabulated form. Okay, so we noted on there were two products, there were various services, so we noted on the services. Okay, after that we have written the values which were given to us based on the question. Okay, now remember these steps. Okay, you have to just follow 3 steps. In 3 steps you'll be able to complete the entire sum. The very first thing is called as, we'll have to note down something called a decision variables. Okay, decision variable meaning your x, what are you naming as x1 and x2? So we'll write here x1 equals to gift A and x2 is equal to gift B. That's the first thing. Second thing is called as objective functions. Objective function means whether the sum is based on maximization or minimization. Now since I told you in this question they are talking about profit, so profit is always maximizing, so I'll write here maximize Z equals to, now here is given 35, so 35 is for x1 and 45 is for x2, so 35x1 plus 45x2. Third, it is something called as subject to constraint. Subject to constraint. Okay, here we have to note down the equations. Okay, now we are going to convert this and this line into equation. So it will become 3x1 plus 3x2, okay, less than equals to this is 3x2 less than equals to 250. Second equation would be 3x1 plus 5x2 is less than equals to 200. So we are converting this into equation. And last we have one non-negative equation whereby we just have to mention that x1, okay, comma x2 will always be greater than and equal to 0. Okay, so first we have to note down decision variable, second objective, third subjective constraint. Final answer, therefore LPP can be formulated as max Z is equal to 35x1 plus 45x2 subject to constraint (3x1 plus 3x2 is less than equals to 250). 3x1 plus 5x2 is less than equals to 200, and x1 comma x2 is greater than or equal to 0. That's it. Okay, now let us read the third question. Nutrition N1 and N2 are required by 2 persons P1 and P2. So now there are 2 persons here, and 2 nutritions are given. So it's basically 2 by 2 base. So first let us draw the table and then we'll see how to post the values. Okay, now let us read the question once again. Nutrition N1 and N2 are required. So we have 2 nutrition or 2 types of product here, N1 and N2 are required by 2 persons P1 and P2. 1 unit of P1 is given. 1 unit of P1 contains 4 units of N1 and 6 units of N2. So it's saying 4 units of N1 and 6 units of N2, whereas 1 unit of P2 contains 5 units of N1 and 4 units of N2. The minimum consumption, now they are giving you minimum consumption, so min consumption. The minimum consumption by nutrition by P1, now it is minimum. So if it is minimum, so you will write greater than, and equals to 65 for P1, and P2 it is 85, so greater than equals to 85. Now the cost per unit of P1 and P2, now see again, now this is related to cost. Now always remember, if it's a sum is related to cost, it will always be minimization. So here I will write cost. The cost of unit of P1 is 8 and that of P2 is 6. Okay, now I'll write here, let the number of units manufactured be x1 and x2. Okay, so again now we'll start with the number one. First will be see, the solving is same. It's the only thing, it will be greater than, and this is based on your cost. So here it will be first point, decision variable. Our decision variable will be x. Let x1 be n1 and x2 will be n2. Second, objective function. So now this is based on cost. So cost it will always be minimization. So minimize z as 8x1 plus 6x2. Third, subject to constraint. So subject to constraint will be 4x1 plus 6x2 greater than equals to 65. 5x1 plus, from here, okay, these are the two constraints. 4x2 greater than equals to 85, and last one we have non-negativity equivalent. So we'll have x1 comma x2 greater than equals to 0. Once you have done that, the same stuff. Therefore LPP can be formulated as minimum z is 8x1 plus 6x2 subject to constraint 4x1 plus 6x2 greater than equal to 65, 5x1 plus 4x2 greater than equals to 85, x1 comma x2 greater than equals to 0.
Okay, now this is the last topic, the most simplest topic, okay, under this video. This is the last topic that we're going to do is LPP graphical method. Now, I can guarantee you all that if you'll practice these 8 type of sum, you all will be able to clear the paper. Those who haven't prepared yourself very well, okay. So, see that after viewing this video, you'll share it to as many, students as possible, those require the help in this particular subject, because this can guarantee their passing marks, okay. So, chalo, let us see the last part, that is LPP under graphical method.
Okay, the question reads out as maximize z or z is equal to 4x1 plus 3x2 subject to constraint 3x1 plus x2 is less than equal to 15, 3x plus 4x2 is less than equal to 24, and we have a non-negativity equation, that is x1 x2 should be greater than or equal to 0. Now in order to solve this graphically, okay, the very first thing, just remember the step how we have to go ahead with the sum, okay. The very first thing that you'll have to do is, number one, first note down the, see in this there are two equations, okay. This is the graphical sum where we have been given two equations. So I'm writing here 3x1 plus x2. Now since they're less than, but we'll have to show it as is equal to 15. Okay, after that create a table. Okay, I'll take that with the help of a ruler. Okay, we will create a box where we are going to find basically the coordinates. Okay, we are basically trying to find the coordinates. So I'll write here, yeah, this is a kind of a table that you'll have to prepare. So I'll write here x1, this is x2, this is x1 comma x2. Okay, remember x1 stands for x, x2 stands for y. Okay, so it's an x and y simultaneous equation based. Okay, In the first I will take this 0, in the second I will take this as 0. Now very simple, in the equation that is 3x1 plus x2 equals to 15, substitute x1 as 0. If I substitute this x1 as 0, I will get 3 into 0 plus x2 is equals to 15. Therefore x2, 3 into 0 will be 0, therefore x2 is 15. So I get the x2 ka value as 15. So this is 0 comma 15. Now same way in the same equation, okay, I'll take now x2 as 0. So I'll get 3x1, okay, plus 0 is equals to 15. So we will get 3x1 is equals to 15. Therefore x1 will be 15 upon 3. Therefore x1 is equals to 5. So I got x1 as 5. So my second point was 5 comma 0. In the same way, now this was for the first equation, okay, first equation ke liye we got the coordinates. Now same way for the second equation, that is 3x1 plus 4x2 is less than equals to 24. So again we will create the similar kind of a table. Okay, so we'll have xy and then we'll have, you know, okay. In the same way, this is my x1, this is x2, this will be x1 comma x2. I will keep first x1 as 0, then I'll keep x2 as 0. Now in the equation 3x1 plus 4x2 is equals to 24. Okay, I'll keep that as equal to, okay. So if I take 3x1 as 0, it will be 3 into 0 plus 4x2 is equal to 24. Therefore x2 will be 24 divided by 4. X2 will become 6. So that is 0 comma 6. In the same way, if I substitute the value of x2 as 0, okay, x2 as 0, so I'll get 3x1 is equal to 24. Therefore x1 will be 24 divided by 3. Therefore x1 will be 8. So this will become 8 comma 0. So very first step whenever you have to solve in graphical method is first get the coordinates of the equations. Next step, now we will be plotting it on a graph. Okay, now if they provide you graph paper in the exam, you can solve it on the graph. If not, you all will have to do it on your answer sheet only or in a supplement. Okay, so we have x and y. Now if you look carefully, we have 0, 15 is the max value here, so we can take it around, I can take it in 2 ka range mein. So I'll take 1 centimeter each. Okay, I'm going to take it 2 centimeter each. So I'll take it in 2 twos. Centimeter will be 1. Centimeter will be 1. But I will be taking 2 values in it. Okay, so what I'll do here is, this is 0, this will be 2, 4, 6, 8, 10, 12, 14, 16. Same way here, 2, 4, 6, 8, 10, 12, 14, 16. Okay, now this is my x-axis that is known as x1 in this sum. This is my y-axis which will be known as x2. Okay, now once we come to the step, where we have, you know, made the graphs, now it's very simple. First thing what we'll have to do is mark the first equation ka coordinates. Now for the first equation, the coordinates are 0 and 15. X is 0, y is 15. So if x is 0, y is 15, so somewhere here my point will be there, first point. The second is x is 5 and y is 0. So here will be my point. Once I got those two coordinates, okay, pass a line passing through it. So that's my first line. Okay, same way for the second. Okay, same way for the second one. Your x is 0, y is 6. So I marked it. Second, x is 8, y is 0. So I've marked that also. Now I will be passing a line through it. Now remember this, the first line was based on the equation 3x1 plus x2 is equal to 15. The second line was on the basis of the second equation, that was 3x1 plus 4x2 is equals to 24. Acha, now after marking this, after graphically plotting it, now we need to find the maximization here. So remember, under maximization you have to shade, we'll have to find the feasible region. Under maximization, the feasible region will always be the inner part. In minimization sum, it will always be the outer part. Since it is maximization, the inner part will be your feasible region. Okay, so we have marked it. So now, which are the points which are touching this feasible region? So I have this 6. I have this point where the lines are intersecting, and I have this 0, 0. Okay, now if you have a graph paper, you can exactly get the values of, accurately get the values of your plot, but always to be on a safer side. Okay, now see, this coordinate is 0, 6, this is 5, 0, this is 0, 0, but we need to find the intersecting point of these two lines. So for that, what we'll do, we will solve the equation simultaneously. So 3x1 plus x2 is equals to 15, my first equation. Second, 3x1 plus 4x2 is equals to 24, that's my second equation. Now I can cut off this, so I'll write subtracting the equation. If I subtract, this gets cancelled off, so I'll have 1x2 minus 4x2 will give you negative 3x2 is equal to negative 24, negative 24 and 15 when you subtract it. Okay, so I'll write 24 minus 15, that is negative 9. So therefore x2 will be, minus minus get cut, 9 divided by 3 will be 3. My x2 ka value is 3. I'll substitute that in any of the equations. So if I substitute in the first equation, I will get it as 3x1 plus x2 is 3 we have got, is equal to 15. So 3x1 will be plus 3, when goes to the other side will become minus, so 15 minus 3 will be 12. Therefore x1 will be 4. 12 divided by 3 is 4. So therefore I get the coordinate x1 comma x2 as, x1 was 4 and x2 is 3. Okay, now once we have got those coordinates, now final step. Now the sum was based on maximization. So it was maximize z is equals to 4x1 plus 3x2. We are finding the optimal solution. Now name the points of your feasibility. So I'll name this as point A, this is point B, this was point C, and this is point O. Okay, so I have point O where the coordinates are 0, 0. I have point A where the coordinates are 0, 6. I have point B, the coordinates are 4, 3, and I have point C where the coordinates are 5, 0. Now we will substitute in this equation. So I have 4x1 plus 3x2. This is x1, this is x2. The answer is 0. For the next, 4 into 0 plus 3 into 6. 3 6 are 18. Next, 4 into 4 plus 3 into 3. So 4 4s are 16. Plus 3 3s are 9. Okay, so 16 plus 9 is 25. And lastly, 4 into 5 plus 3 into 0, so 4 5s are 20. Now from here, the maximum, since it is a maximization sum, the maximum value is 25. Therefore, I'll write, that's my final answer. So my optimal profit is max. So my optimal profit equals to max Z, which is 25 rupees at B where x1 is equal to 4 and x2 is equals to 3. That's my final answer. Okay, so this is how you all had to solve graphically the maximization sum. All remember in maximization the inner portion gets shaded. Similar sum if it was given in minimization, the outer portion would have been selected, and then these would have been your point or your coordinates. Okay. Chalo, I hope everyone have understood this sum based on maximization under graphical method. Now we will be taking up sum based on minimization under graphical method. Okay. Okay, now this sum is based on minimization. If you read the question, minimization z is equal to 4x1 plus 2x2 subject to constraint 3x1 plus x2 is less than greater than equal to 27, x1 plus x2 21, x1 plus 2x2 30. Now if you look carefully, there are three equations here. We have first equation, second equation and third equation. So solving will be exactly same. Okay, chalo, so we will start the way how we did maximization. So first I'll take the first equation. 3x1 plus x2 is equals to 27. Okay, once we have taken that, now I will make the table. In the exact same way, okay, the way how we solve the first part, exactly same way. Okay, x1, x2, x1 comma x2. First x1 will be 0, next x2 will be 0. Now what we'll do here, I'll show it here itself only. If I take x1 as 0, so this goes off. So my x2 ka value will become 27. So that my first equation is 0 comma 27. Now if I take x2 as 0, so I'll have 3x1 is equal to 27. So 27 divided by 3 is 9. So my x1 ka value will become 9. So 9 comma 0. Okay, we can solve it directly. Once you get a hang of it, you all can do it directly also. Second equation was x1 plus x2 is equals to 21. Again, we'll create a table. Okay, we have x1, we have x2 and x1 comma x2. First x1 will be 0, next x2 will be 0. Now if I give x1 as 0, x2 is 21, so it is 0 comma 21. If I give x2 as 0, my x1 will become 21, so it will be 21 comma 0. Third, we have x1 plus 2x2 is equals to 30. So again we will make the table. So I have x1, x2, x1 comma x2, 0, 0. So again if your x1 is 0, it will become 30 divided by 2, so I'll get x2 as 15, so 0 comma 15. If my x2 is 0, x1 is 30, so 30 comma 0. Okay, first, second, third, all the three equations we have found the coordinates. Now we will solve this graphically. Now x is 30, so I'm just checking till where can I get that value. Okay, I have made this here. So I'll be just jotting it now. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Still, I have a limitation page. You all can take the entire graph, the entire page. Okay, always use the entire page for this. 4, 5, 6, 7, 8, 9, and 10. Now, since everything is in 3 times table, we'll go with 3 times table here. So it will be 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Same way here, 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. This is my x1, this is my x2. Okay, so we will start now. The first point, 0, 27, x is 0, y is 27, so that's my first point. Second, 9, 0, x is 9, y is 0, so that's my first equation. Okay, so this equation was 3x1 plus x2 is equals to 27. Now next, 0, 21, so this is that point, and 21, 0, so this is the second point, so I'll mark that. That's our second line basically. Okay, so I'll just note down this. This equation was x1 plus x2 is equals to 21. Third one, when x is 0, y is 15, and when x is 30, y is 0, so that's my third equation. So I'll just draw a line passing through it. Okay, so we have got a 3 line, we plotted here, so I'll just write this equation. This is my third line ka equation, that is x1 plus 2x2 is equals to 30. Okay, now we have got all the stuff done. Now the sum is based on minimization. Remember, under minimization your feasible region will always be the outer part of your graph. So now which are the points which are in the outer part? So I have one, this is my second point, this is my third point, and this is my fourth point. So I'll name it. I have point A, I have point B, C, and point D. These 4 points are there in my outer column. Okay, now point A ka value is very simple, that is 0, 27, and last value D is also simple, is 30, 0, but I need to find B and C ka value. So for that I will have to solve it simultaneously. Okay, though I can come to know it's around 3 and 18, but to be sure we will solve it simultaneously. Point B is made up of equation, the first equation, which is 3x1 plus x2 is equal to 27, and the second equation, which is x1 plus x2 is equal to 21. So I'll subtract them. If I subtract, this goes off, so it will become 2x1 is equals to 6, x1 is equals to 3. See, that we could come to know here also, okay, x1 was coming around 3, but to be more sure on it, now I'll substitute 3 in the first equation. So I'll get 3 into 3 plus x2 is equal to 27, so that is 6. 6 when goes to the other side, it will become 3 3s are 9. 9 when goes to the other side, it will get subtracted, so it will be 27 minus 9, so it will come to 18. So my x2 ka value will become 18. So here x1 comma x2 is 3 comma 18, so which we could see here also, it's coming to 3 and 18, so I could have actually got it here. Now this comes around 12 and 9, just to confirm it. Now this is intersection of the second equation, x1 plus x2 is equals to 21, and the third equation, x1 plus 2x2 is equals to 30. Again I will subtract it, this goes off, so I'll have negative x2 is equal to negative 9. So when I cut it, I get x2 as 9, so we can see x2 is 9. So I'll substitute now this in the first equation. So x1 plus 9 is equal to 21, so x1 will be 21 minus 9, which will come to 12. So therefore your x1, x2 was 12 comma 9, which is perfectly matching 12 comma 9. That's it. So now final answer mein my minimization z is equal to 4x1 plus 2x2. Okay, now here the points are A, the coordinates was 0 comma 27. Point B we found already, that is 3 comma 18. C also we have found, which was 12 comma 9, and D is already given 30 comma 0. That's my D point. Chalo, we'll just substitute now. 4 into 0 plus 2 into 27. So that will be 27 into 2, 54. Okay, so we'll write this as 54. Now 4 into 3 plus 2 into 18. 4 3s are 12, 18 2s are 36. So 36 plus 12 will give you 48. Next 4 into 12 plus 2 into 9. Now 4 12s are is 46 plus 2 9s are is 18. So when I add up, it comes to 66. Last 4 into 30 plus 2 into 0. So 4 into 30 gives you 120. So here your answer, the lowest value which you can see here is, see, since the sum is based on minimization, the lowest value is 48. So I'll write here, therefore, now this is minimization, so optimal cost is min z, which is rupees 48 at B, where x1 was 3 and x2 is 18. Okay, so this is how you all had to solve the sum based on minimization under graphical method under the chapter linear programming project or LPP. Okay, so in this we completed both the sum. One we took off maximization and the other one we have taken off minimization. Okay, I hope everyone have understood this. With that, we will be ending this video here. Thank you.